Hello, welcome to College Algebra. In this lesson, we're going to be taking a look at how to use Cramer's rule to solve systems of linear equations. And I guess to jump right into it, before you can understand Cramer's rule, you have to understand what it means to find a determinant. And so what I've done here is I've copied down the definition for finding a determinant of a 2 by 2 matrix. It says the determinant of the matrix A, C, B, D is denoted. Here I want to point out that the notation for finding a determinant looks exactly like absolute value. So if you ever see a matrix with the absolute value symbols, that means find the determinant. And then here's the formula for the determinant. It says you're going to multiply A times D and subtract B times C. So here's A and D. It's like you're going to multiply across this way and then multiply across this way, and you're going to subtract the results, okay? So what I've done here is I've copied down an example. This is going to be an example we're going to look at. Again, I'm going to take my own approach to doing this. I have a technique, I like to call it the fish method, where it says you're going to start at the 5 and you're going to come around and make a fish symbol, okay? Now, what that helps you remember, it helps you remember where to start and then the direction you go in. So, to find this determinant, we're going to start at the 5 and come down. That's going to be 5 times negative 4. When you turn the corner, you put a minus, always a minus. And then you're going to come around and multiply this way, 3 times negative 2. So again, starting at 5, that's 5 times negative 4 minus 3 times negative 2. And then we need to work that out. So 5 times negative 4 is negative 20. You could take this negative here, the subtraction with the 3, and you could say that's negative 3 times negative 2, which gives us a plus 6. And then you're going to add those together. So negative 20 plus 6 is negative 14. And that is finding the determinant of a 2 by 2 matrix, okay? So to add to that, we're going to look at the calculator. If you have a Casio ClassWiz, Casio FX991EX, the calculator does a great job of doing a determinant for you. So let's look at how to use the calculator here. First, we want to press the menu button. And if we scroll all the way over, option number 4 is matrix. And we're going to select option 4. And we're going to define our matrix. So let's define matrix A. How many rows does it have? Okay, so the rows go across. Whoops. 1, 2. It's got 2 rows. So we're going to say the number of rows is 2. And the columns go up and down. So 1, 2. So our matrix has 2 columns. And then you simply fill in the numbers, okay? So see, we're starting in the upper left. We're going to hit 5 equals, 3 equals, negative 2 equals, and negative 4 equals. Okay, so then once you've got that matrix input, then you want to go to the options button. And if we scroll down, define, edit, calculate. Okay, matrix calculate. We want to select number 3. And we're going to hit option, scroll down, and we want determinant. So that's number 2. And then we're going to have to hit option again. And notice number 3 is matrix A. So this is going to find the determinant of matrix A that we just input. And with any luck, we're going to get the same answer we just calculated. So we're going to hit equals. and we get negative 14, which is the answer we just got. So notice the Casio ClassWiz has the ability to do matrices and find the determinants for us, okay? So we will be coming back to this occasionally. All right, next. Now that we know how to find the determinant of a 2 by 2 matrix, now we can look at what Cramer's rule says. So here's Cramer's rule for a 2 by 2 system. It says the solution of this system right here, which we have two equations with two unknowns, the x and the y, those are our variables, is given by, and then these are the formulas. X is d sub x divided by d, and y is d sub y divided by d. And then down here it specifies what those represent. So d is the determinant, and if you look at those variables that are in there, a1, a2, b1, and b2, you're going to notice that those are the coefficients of the x and the y variables, okay? So what I call regular D, the determinant, and notice that that is in both denominators. This determinant is from the values of the coefficients of x and y. And then d sub x, the way I remember d sub x, it says replace the x values with the constants. So here we have C1 and C2. If you're finding d sub x, you're going to replace the a1 and a2, which came from the x's, you're going to replace those with the constants. And then notice b1 and b2 stay in there. And then you'll have to calculate that determinant. And then d sub y is the determinant where you replace the y's with the constants. So again, for d sub y, instead of using b1 and b2, the numbers that come from the y's, you're going to use the constants in that place, okay? So in order to find the solution of the system, you're going to have to calculate three 2 by 2 determinants, okay? So I have an example, and we're going to break this down and look at how this works, okay? And this one I'm going to try to color code it. All right, so here we go. We've got blue for the x's. We've got green for the y's. And then let's do red for the constants, okay? So the first determinant that I'm going to find is regular D. And if you remember, regular D is the coefficients of the x's and y's, okay? So trying to color code this, that's going to be 2 and 3 for the x's, and 5 and negative 2 for the y's. And then just like we did in our previous example, we're going to do the fish technique, starting at 2, coming around. That's going to give us 2 times negative 2. Remember, we always put a minus, and then we turn the corner and come down. 5 times 3. And that's going to be negative 4 minus 15, which is negative 19. And we're going to put a box around that because that's important. That's our regular D. Okay, next, we need to find D sub x. And remember, D sub x says instead of using the x's, we're going to use the constant. So 7 and 1 where the x's were. And then 5 and negative 2, we actually get to keep the y's. And then using the fish technique, we're going to get 7 times negative 2 minus 5 times 1. 2 times 7, that's negative 14 minus 5, which is negative 19. And that's interesting that that actually matches regular D. Okay, so there's D sub x. And then we need one more determinant. We need to find d sub y, okay? So d sub y says that we're going to get to keep the x's this time. So the 2 and the 3 we get to keep. But instead of using the y coefficients, we're going to use the constants. So 7 and 1 take the place of the y coefficients, okay? And then again, we're going to use the fish technique coming around. That's going to be 2 times 1 minus 7 times 3, which is 2. 3 times 7 is 21, which is negative 19. Wow, interesting. Everybody came out. This is not going to happen this way every time. You're not going to get the same value for all three every time, okay? This is unique. And so what we're going to do to finish this then is we're going to come over here to our Cramer's rule, and we're going to say, okay, if I want to know x, that's going to be d sub x divided by d, okay? So x is, our d sub x was negative 19. Our regular d was negative 19. And of course, anything divided by itself is 1. So the answer for the x coordinate of the solution is 1. And then notice what Cramer's rule says. It says, hey, if you want to know what y is, that's d sub y divided by d. D sub y was negative 19. Regular d, again, was negative 19. And that's, again, is going to be 1. And so the solution to this system, if I was to write the answer, I would say, hey, the solution is the ordered pair 1, 1. Okay, that, grab my highlighter, that is the solution of the system. Now that's going to be the point of intersection, okay? So what we're going to do next, now that we know the answer, and this is showing all of the work here that you might be required to show if it says solve using Cramer's rule. Now we're going to pull up the Casio, and I'm going to show you how to check this, okay? So what we want to do to actually solve this system is I'm not going to check this with matrices. The calculator has a much better way to solve this. So we're going to go to the menu button, and we're going to scroll all the way down to where we have the equation / function option. We want to select option A here. So we're going to hit equals. And what we have here is a system. Whoops. This is a system of equations, okay? So on the calculator, that's going to be option 1, simultaneous equations. And then it wants to know the number of unknowns. Well, we have x and y. We have 2 unknowns. So we're going to say 2. And then if you notice, it's going to allow me to fill in all of the values for both equations. All right, so starting with the first x, that's going to be 2 equals 5 equals 7 and equals. Okay, so there's our first equation, 2x plus 5y equals 7. And then we can put in the second equation, 3 equals, okay, so this 2 is negative. We're going to say negative 2 equals, and 1 and equals. Now, I've got all the equations input. If I hit equals again, it's going to tell me the answer for x. It's going to say, hey, your x coordinate is 1. And if I hit equals again, notice it says y is 1. So again, the Casio ClassWiz has a built-in system solver. It will solve the system of equations for you, but it's not going to tell you how to do it with Cramer's rule. So if you're required to show the solution, showing your work using Cramer's rule, you're going to need to know how to do this process, okay? So there's an example of Cramer's rule for a system of 2 by 2 equations. All right, if we scroll down a little bit, We're also going to have to know how to use Cramer's rule for a system of 3 by 3 equations. 3 variables, 3 equations, and this is going to be more exciting, okay? Going to take a little bit more work. So let's point out the important stuff. First of all, it says Cramer's rule for a 3 by 3 system. The solution of this system of equations is given by, and then here are our Cramer's rule formulas. Right here. It says if you want to know what x is, that's going to be d sub x divided by d. And so here is d sub x, and here is d. Again, notice that d, what I call regular d, those values for that determinant come from the coefficients of x, y, and z. You've got your a's, your b's, and your c's. Those are the coefficients of your x's, your y's, and your z's. So that's regular d. D sub x says replace the x coefficients with the constants. So here the constants are going to take the place of the x coefficients. And then if you want to know what y is, that's d sub y over d. And d sub y, notice it says replace the y coefficients with the constants. And then lastly, z, d sub z over d, where d sub z is the determinant, but you're going to replace the coefficients of z with the constants. So that means we're going to have to calculate 1, 2, 3, 4 3 by 3 determinants, and we've not even talked about how to find a 3 by 3 determinant yet. I will say that the textbook does a good job of explaining the mathematical concept of a 3 by 3 determinant, but it is rather involved and a little bit higher level than what I want to present, I guess. If there's an easier way to do something, I want to show you. And so I'm going to give you my take on how to find a 3 by 3 determinant, okay? So just bear with me. This is going to take a little while to get through. Here's our example. We have a system of 3 equations with 3 unknowns, and the instructions say solve using Cramer's rule. So we're going to find 4 determinants. All right, so strap in. It's going to be a little bit of a bumpy ride. And we're going to start with regular D first, okay? So again, if I color code this, I'm not sure that I have enough colors. Let's see here. I don't know. I'll give it a shot, okay? So let's say that the constants, we're going to go with red. The x coefficients in blue. The y coefficients in green. And what is that? Is that purple? I'm not sure. Maybe that's just darker blue. But we'll try to color code that. All right, here we go. So for regular D, that's going to be 3, 5, and 2. And then 2, notice that this y has an understood -1 for his coefficient, and 3. And then for the little bit darker, 2, -6, and 3. And so we're going to have to find the determinant of this 3 by 3 that we have not seen before using my secret math ninja technique. The first step is to take the first 2 columns, and we're going to simply copy and paste those here on the outside. 3, 5, and 2. 2, -1, and 3. Now there's no reason to do that except that it makes my shortcut work, okay? That's why we're doing it. It just makes the shortcut work. The first thing we want to do is, starting up here at the 3, we want to multiply down on the diagonal. So 3 times -1 times 3 makes -9. And then we scoot over 1 and we multiply down on the diagonal. 2 times -6 times 2. Let's see, that's -24. And then one more time on the diagonal. 2 times 5 times 3. That is a positive 30. So far, so good. So we're going to multiply, 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 add them up. Multiply, 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 add them up. So to do that, we're going to grab the calculator and clear and menu 1. All right, here we go. -9 minus 24 plus 30 is -3. All right, so that is our first piece of the puzzle. That's not the answer. That's just the first piece of the puzzle. And then we're going to change directions, and I'm also going to change color, and we're going to multiply going up on the diagonal. And I chose red for a reason. That is to remind you that when you change direction, you have to change the sign. So just like when you're in red in your checkbook, that means you're in the negatives. Here, when I multiply going up, whatever I get, I'm going to have to negate it. I'm going to have to change the sign, okay? So 2 times -1 times 2, that's -4, but I have to change the sign so it'll be +4. Got it? Next diagonal, okay? That's going to be 3 times -6 times 3. And that's going to be -54. Change the sign, 54. And then one more time on the diagonal, 3 times 5 times 2. That's going to be +30. Change the sign, -30. Okay, so got that part? That's multiply, 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 add them up. So 4 plus 54 minus 30. 4 plus 54 minus 30. 28. Okay, so that's 28. And guess what? We're still not done. The last piece of this puzzle. Notice we've got now 2 numbers hanging off the end, and we now need to add those up. Okay, so here, finally, we're going to be able to get regular D. What is 28 plus -3? Well, that's the same as 28 minus 3, which is 25. All of that work just to get one of the 4 determinants. Okay, so guess what? We're going to get to do all that 3 more times. I warned you. Here we go. Next step. Why is it not? There we go, scrolling. D sub x. And for d sub x, if we go over here, we're going to replace the x's with the constants, okay? So that's going to be 1, 3, and 4, and then 2, -1, and 3, and last but not least, 2, -6, and 3. And then we're going to get to do this shortcut again. Okay, so remember I said for doing the determinant of a 3 by 3, the first step is to copy and paste the first 2 columns to the outside, and then going down on the diagonal. Okay, so first diagonal, that's going to be 1 times -1 times 3 makes -3. Next diagonal, 2 times 6 is 12. 4 times 12, 48. And one more time, 3 times 2 is 6. 3 times 6 is 18. multiply, 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 add them up. And so that's going to be negative 3 minus 48 plus 18, negative 33. And then we're going to change direction, going up on the diagonal, which means we're going to change the sign. Okay, so 4 times negative 1, that's negative 4 times 2 is negative 8. Change the sign, gives me 8. Next, 3 times 6 is 18. Negative becomes a plus. And one more time. 3 times 3 is 9. 2 times 9 is 18, but it becomes negative 18. Add them up, gives me an 8. Because the 18s cancel, leaves me the 8. And then guess what we get to do here for the last step? Multiply, 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 add them up, and we're going to have 8 plus a negative 33, okay? So d sub x is going to be 8 plus negative 33, which is the same as 8 minus 33, which is negative 25. And if you're wondering why am I going to the calculator so much, it's because, well, really, I don't trust myself. I just want to make sure that it's right. Next, all right, let's scroll up some. Next, we're going to do d sub y. So the x's, which were 3, 5, and 2, get to stay the same. The y's get replaced with the constants, 1, 3, and 4. And the z's get to stay in there. So that's going to be 2, negative 6, and 3. And then we're going to go through the shortcut again. Okay, so copy and paste 3, 5, and 2. Copy and paste 1, 3, and 4. And then going down on the diagonal. 3 times 3 is 9, times 3 is 27. Next diagonal, negative 6, negative 12. 5 times 2 is 10, times 4 is 40. Add them up, and that's going to be 27 minus 12 plus 40, 55. Now, let's change direction. Going up on the diagonal, 3 times 2 is 6. 2 times 6 is 12. Don't forget to change the sign. Next diagonal, 4 times 6, 24. 24 times 3, gonna need a little help with that. 24 times 3, 72. That's a negative, makes it a plus 72. And one more time, that's going to be negative 15. Add them up. Negative 12 plus 72 minus 15, 45. And then to finish it off, 45 plus 55, that's going to give us d sub y is 45 and 55. What is that, 100? D sub y is 100. Come on, scroll up. There we go. Scroll. D sub z. Last time through. Okay? So, 3, 5, and 2. The z's get replaced with the constants, 1, 3, and 4. And then the y's stay the same. And then I've got to recall what were the y's. 2, negative 1, and 3. 2, negative 1, and 3. And here we go again. Come on, scroll. There we go. Let's see, copy and paste. 3, 5, and 2. Copy and paste. 2, -1, and 3. And then multiply down on the diagonals. -3 times 4 is -12. 6 times 2 is 12. And 15. Whoops. Add them up. Cancel. 15. All right. Change direction, which means change the sign. That's going to be +2. That's going to be -27. And 20 times 2 is 40. -40. Add them up. 2 minus 27 minus 40 is -65. And then to finish it off, add them up. So D sub Z is -65 plus 15. Let's see, that's going to be -50 if I'm not wrong. And let's check that real quick. What was it? -65 plus 15. -65 plus 15. Yes, -50. Okay. Whew, my gosh. Okay, so now we're all but done. At this step, we can now go back up here to Cramer's rule, and we can say, okay, if I want to know x, that's going to be d sub x over d. So x is, here's d sub x, which is -25, divided by d, which was 25. And so we now know x is -1. Y. Y is d sub y over d. That's going to be 100 divided by 25. Why did I write a 2? That's going to be 4. And if I could get this to scroll up, z is d sub z over d. And d sub z is -50 over 25, which is -2. Now remember, when you get done, these are the answers, but we really need to write that solution as an ordered triple this time, okay? So the solution is -1, 4, -2. And if you're wondering, does it matter what order I write that in? The answer is absolutely. Your ordered triple has to be in alphabetical order. X, Y, Z. That's the solution. And if you notice, if you are asked to solve a system of 3x3 equations using Cramer's rule, this is not something that you can do mentally. You're not going to be able to solve this mentally with Cramer's rule. You're going to have to do it manually, and there is a heck of a lot of work involved. Now, the nice thing is, after you get all of this work done, the Casio has a super easy way to check this, okay? So we're going to go back to the menu and scroll down to the equation/function option. And we're going to choose simultaneous, number 1. And this time the number of unknowns was 3. And you're going to be able to enter your coefficients for the equation. So again, if I could get this to scroll down to where I can see my equations. There we go. So going across, that's going to be 3 equals 2 equals 2 equals, and then notice it skips over to the constant, and that first constant is 1. So you're going to input the entire first equation and then to the second equation. 5, -1, -6, 3. Last equation, 2, 3, 3, 4. And then if I hit equals one more time, look at that. It's going to say x is -1. If I hit equals again, y is 4. And z is -2. And then notice that that does verify our solutions, -1, 4, and -2. If I could bring that back up, there you go. Z is -2. I can hit the back button, I think, or the up. There we go, up. Y is 4, x is -1. -1, 4, -2. So the calculator is nice, okay? But if you're having to solve a system using Cramer's rule and you have to show your work, just writing this answer without any work, that's not going to cut it. You're going to have to know how to use Cramer's rule here. All right, so that's going to be the end of this lesson. That's pretty much it for Cramer's rule, showing you how to do a 3x3 system and a 2x2 system. Let me just say, if you have any questions or comments, please put those in the comment section below, or feel free to text me if you want. And I'll see you in the next lesson.